With the applicable device group open on the map, on the Circuits VCs tab, click Create. The provisioning wizard opens. The first page populates with the Carrier Ethernet service types by default. In the Technology drop-down list, select MPLS TE. The page updates to display the MPLS Tunnel Engineering service types. In the Service Type list, select Bidirectional TE Tunnel. In the Select Profile drop-down list, accept the default selection, which is blank. Note, when provisioning tasks include common sets of configurations that users provision on a regular basis, they can define those parameters in profiles to automate and expedite complex service provisioning. Then, users can apply a profile based on the service that they need to provision. In this case, you are configuring specific settings, so you do not select a profile. To continue, click Next. The Customer Service Details page opens. Beginning on this page, the wizard provides a Cancel button. Important note, use caution when canceling the provisioning process. When you cancel, the wizard automatically returns to the initial page with its default settings and discards any information that you have added. The system does not prompt or alert you that it will not retain your changes. Because you are provisioning a bidirectional traffic engineering tunnel that will support services for a specific customer, in the Customer drop-down list, select the customer name. In the Service Details section, type a name for the tunnel and type additional information to describe its use. In this case, you plan to provision the tunnel with a working and a protected path. In the event that the working path fails, to help ensure that traffic adheres to the SONET 50 millisecond standard restoration time, while transitioning traffic to the protected path, select the Wrap Protection checkbox. To enable the Operations, Administration, and Management protocol for fault management, which supports metrics reporting in various application areas, accept the default selection of the Enable Fault OAM checkbox. Because automated traffic routing does not apply to bidirectional tunnels, we do not select the Enable Auto Route checkbox. For more information, refer to the Provisioning Circuit Emulation Services job aid. In this case, we are configuring a tunnel with working and protected paths. To allow the system to manage a working path failure scenario effectively, select Enable Lockdown. For more information on the lockdown command, refer to the job aid. To configure bidirectional forwarding detection, which helps expedite forwarding path failure detection, accept the default selection of the BFD settings checkbox. You can configure the related BFD settings as needed in a later step. And, in this case, you are provisioning working and protected paths. To configure the system to present a preview of the CLI code that it will deploy to the endpoints, before deploying it, accept the default selection of Preview. Cisco recommends that you preview CLI code before deploying the configuration. This approach helps you to avoid unexpected results or operational issues. When you determine that you need to make changes, you can return and make the corrections that you need. To configure the tunnel endpoints and attributes, click Next. On the tunnel creation page, in the Create Tunnel section, to indicate the source endpoint device, click the device icon on the map. The system populates the source field, and, because we selected an NCS 4200 series device, the system populates the source routing process drop-down list with the applicable routing protocol automatically. Note: an administrator must configure the routing protocol on the source and destination devices before you can provision tunnels on the devices, or the process will fail. Next, take the same action to select the destination device and routing process. In the Global ID field, accept the default identifier value, which allows the system to assign a unique identifier on the back end. In this case, we do not need to configure affinity on the devices. And we need to ensure that tunnel provisioning occurs successfully, regardless of other tunnels using the same endpoints. To configure the tunnel to have the highest priority during initial tunnel provisioning, in the Setup Priority field, type 1. Because the customer's tunnel is supporting high priority traffic, you do not want the provisioning of another tunnel to be able to preempt this one. To configure the tunnel to have the highest priority after it is established, in the Hold Priority field, type 1. To indicate that the tunnel use available bandwidth without an overage when traffic is peaking above it, in the Bandwidth Pool Type drop-down list, we accept the default selection of Global. To define the maximum amount of bandwidth that the tunnel traffic can consume, in this case, a gigabyte, in the Bandwidth field, type the amount in kilobytes. In the BFD Settings section, the minimum interval defines the time interval at which the endpoints exchange contact confirmation messages. Since shorter intervals require additional CPU processing time and cause additional traffic, we accept the system default interval. We also accept the default multiplier, which indicates the number of contact message failures that must occur consecutively before the system receives a down notification. To configure the working and protected paths, click Next. The channel to which you assign CEM services defines the path, or paths, that the traffic will use to traverse the network. When configuring paths, you can allow the system to identify the route automatically, or you can specify the devices and interfaces that will manage the traffic. In this case, we want to allow the system to determine the working path for the tunnel automatically. To open the Protected Path configuration, click Protected. In this case, we also want the system to determine the protected path. With configuration complete, we are ready to start the provisioning process. To continue, click Submit. The system runs provisioning to determine whether the configuration can occur successfully on the device endpoints, and because we selected Preview as the deployment action, opens the preview page. At this point, you can evaluate the CLI code that the system will deploy to each of the tunnel endpoint devices, and review the status section to see if the system returns a successful result. To check each endpoint, select it in the Devices drop-down list. In this step, if you need to change any of the settings to obtain successful results, you can return to the Provisioning Wizard and make the changes that you need. In this case, the CLI code is correct, and provisioning on each endpoint is returning a successful result, so we click Deploy to start tunnel provisioning. When provisioning is complete, the system reports the result. Note that the length of the provisioning process depends on the complexity of the configuration that the system is deploying. To continue, click Close. To close the provisioning wizard and monitor to determine when the tunnel is available, click Close. Progressively, the system discovers the service and reports its operational and serviceability states. With the tunnel operational, you are ready to provision the T1 service that will support the customer's traffic. Because you are provisioning the service on the same endpoint devices that are supporting the tunnel, you have the applicable device group open on the map. To begin, open the Provisioning Wizard. In the Technology drop-down list, select Circuit Emulation. In the Service Type drop-down list, select the Data Transmission Rate. In this case, you don't need to apply a profile. To configure the service details, click Next. To identify the service user, in the Customer drop-down list, select the customer's name. To have the service operationally up when provisioning is complete, accept the default selection of the Activate checkbox. In the Service Name field, type a name for the service that makes its use recognizable. To indicate the use of the service, in the Service Description field, type additional information about the service. To preview the CLI code before deployment, in the Deployment Action drop-down list, accept the default selection of Preview. To configure the endpoint, click Next. Because you are assigning the service to the channel that you provisioned, on the map, click the icon of the same device that supports the tunnel source device. The system applies the icon to the device icon on the map. And in the Working Path section, it populates the port name drop-down list with the interfaces or ports that are available for the service. To configure the interface that will become the endpoint, in the port name drop-down list, select the interface. When you select the interface, the page refreshes to provide only those settings that apply to the service. To configure the system to obtain the clock rate from the device that supports the other endpoint, in the Clock Source drop-down list, select Internal. Because T1 is a constant bitrate service, you do not need to apply a quality of service profile, which in most cases manages bandwidth. To configure the Z endpoint, click Next. On the Z endpoint page, you select the same device and interface that are supporting the tunnel's destination endpoint. In this case, you select the same clock source as the endpoint. To define the attributes of the traffic that is using the service, click Next. When you open the Transport Settings page, the Frame Type drop-down list is read-only and populates based on the type of service that you are provisioning. In this case, the system is transporting T1 traffic over a packet network, which uses the structure-agnostic TDM over packet frame type. Device configurations include default values for transport settings. While you can make changes here that will overwrite the default values, in this case, we can allow the system to apply the default setting values. We also do not need to add a real-time transmission protocol header or compress RTP to reduce overhead. In the SUDOR Settings section, you assign the T1 service to the tunnel that you provisioned previously. Because the tunnel is bidirectional, we can accept the default selection. In the Preferred Path drop-down list, select the bidirectional tunnel. When you select a tunnel, the system opens the Allow Fallback to LDP checkbox and selects it by default. In a channel failure scenario, this setting allows the system to revert to using the MPLS label distribution protocol for communication. To support extending service provisioning functions, system users can continue and select the templates containing the CLI code that they need. In this case, we do not need to include additional CLI code, so we are ready to start the provisioning process. To complete the process, click Submit. After reviewing the CLI code that the system will provision on each endpoint and reviewing the provisioning status, we can deploy the CLI code. Then, we can monitor and validate whether service provisioning is successful and the service is operationally up.